Welcome. This is Mike Bordenaro from the Asset Leadership Network, and I am very happy to be involved in today's webinar, which is a little different. We've been doing a series of presentations on the Asset Leadership Network work groups, and we've had a few special presentations, and this one is a very special presentation. We are fortunate to have the National Institute of Building Sciences, buildingSMART Alliance thought leadership team, not the entire thought leadership team, but some of the team, to present on both commercial and federal implementation case studies. And since we're thought leaders, we're also presenting some very future forward-looking implementation possibilities by James Salmon. It's been my privilege to work with Finance Jernigan, Kimono Newman, James Salmon, and to have Dara Duragi join the buildingSMART Alliance Thought Leadership, for which I'm also the secretary. And today's webinar is going to be run by Kimono Numa. I just wanted to thank those who are attending and thank the thought leaders for putting together this presentation. So now I'll hand it over to you, Kimono.
Great. Thanks, Mike, and thank you to our presenters and to everybody that's attending today. This is the Asset Leadership Network series, one of the series that we've been having every week, and this week's series is on data and buildings as assets. We'll have 4 speakers. It's sponsored by the National Institute of Building Sciences buildingSMART Alliance, and as Mike mentioned, we are the Thought Leadership Subcommittee of the buildingSMART Alliance. And we are tasked with looking at what's happening, the trends in the industry, and actually pushing things forward, prototyping. This is our what we call a Trello board, where we post information and communicate with each other. We have quite a large group in the thought leadership, and we welcome others to join the buildingSMART Alliance and the Thought Leadership Subcommittee. So with that, just a few housekeeping notes. We have in the GoToMeeting box on the right side, there's a question box where we'll be taking questions. We're going to leave some time toward the end of the webinar to have a discussion. And with that, I'd like to kind of start from framing this from a perspective of where the world we used to live in used to look like this. We were tethered to a wall or the ground. And we had information in documents, either static paper documents or even digital files that are hard to get information from. And then the world changed, and we got used to being untethered and being able to get into mobile devices like this. But they were bricks, basically. They were hardware that you had to kind of manually put information into, and when a new piece of hardware came along, you basically threw that one away and moved on to the next one. And then the iPhone and the Android came around, and absolutely everything has changed. It's changed our expectation of how we get to information, and it's changed the way we interact with our world. And we see that as an opportunity from the buildingSMART Alliance perspectives and the industry's perspective and asset leadership perspective. If we can use these technologies, modern technologies, and move forward to a way that we can actually access and interact with the world around us, the assets and the buildings and facilities around us, the way that we've come to be used to working with information like finding an Uber. So with that in mind, this session is really about the opportunities that we see, and it's not really even about the future, it's about the present. How do we bring the building industry and the asset world into the present and use these technologies? So our first speaker is Finance Jernigan, author of Big BIM, Little BIM, and the latest book, Big BIM 4.0. Finance, welcome to the webinar.
Yeah, thank you, Kimon. I'm real happy to be here and happy to talk about what is a topic very close to my heart. Spent a lot of years on this. Can we go to the next slide then, Kimon? Okay, so I'm going to kind of continue Kimon's framing of the issues and framing of some of the things that our clients have found to be critical in the last 10 years especially. Over the last 20 years, a lot of the energy from a national and international level has gone to building standards that really are intended for, largely for a distant future vision that has always appeared to be somewhere out there, but we're not going to, it's going to be a long time till we get there. As Kimon said, as the iPhones and iPads and the connected technology has come along, what started to happen is we've been moving away from the core of file exchange, welded together monolithic application kind of directed tools that really are now becoming a artifact of the last century. And what we're running into is a situation where everybody except for the AECO industry is really working with standards that are very flexible and easy to use in the real world. There's actually a movement out there right now that it's starting to envision what we're up against here as being the fourth industrial revolution. It's been said that sometime in 1999 at 12:01 p.m. the world changed. Suddenly we went from the information age, which was very file exchange oriented, to the connected age where all the technologies have started to fuse together, and there's a blurring of the line between the physical and the digital part of our world. And that's really what we're up against right now. We have things that are still tied into the computer, they're still tied to file exchanges, whether they're digital file exchanges or paper file exchanges, and yet most of our world is now working with something else. And in the AECO industry, we need to find ways to move beyond that. Come on, can you advance? Next slide. What's ended up happening, because we've been so focused on what I call little BIM, which is very much the file-centric desktop software side of our world, the focus has tended to be on design and construct, the design and construction part of our business. It's largely ignored the balance of our world, the 82% that's outside of that, even facility management and operations, which is a really critical part, has gotten very minimal touching in this area. And so we need to move beyond that. And what we've seen is our clients are really focused on moving beyond that, beyond the just design and construct. It's now becoming imperative that things move from construction into operations and maintenance, and it's starting to become more important. I think you'll start hearing when James starts talking about some of the issues associated with funding and financing, that whole recapitalize, dispose, acquire piece, and how that affects the design and construction and all the rest of the industry, because we're starting to, money, time, buildings, everything is starting to merge at this point. Come on, one more. Just so that this doesn't all seem like something out of the blue, that we're sitting around just postulating about possibilities. We started back about 2000. Kimon and I actually worked with the Coast Guard back at that time, looking at ways to make these transitions. And in about 2008, Mike Bordnero and Kimon put together a program that's called the BIM Storm. Many of you have probably experienced it. If you haven't, you should. And they continue to this day. So since about 2008, BIM storms have been used as a living laboratory to test these concepts. And many people who have gone down the road of trying the BIM storms have already found many of the solutions they're very much within our reach, very much within what is available today. These are not long-term things that nobody can do. And in many cases, they're even simpler to do than the old way. One more, come on. One thing that BIM storms have clearly shown, and this is actually a slide from the very, very first BIM storm back in 2008, the amount of technology tools that can all be interfaced and sort of jumping beyond many of the interoperability problems we used to discuss back in the last century, have now they actually kind of go away. They don't go away, but they become less of an issue. And this graphic is just to show some of the data exchanges and information exchanges that happened in the very, very first BIM storm. Many more have been done now. Actually, Kimon is going to show some project stuff at the end that talk about how these things all come together at a much bigger level now. It's become much more sophisticated, much more nuanced, much more accurate over the years. And basically what's happening is Big BIM, or what I call Big BIM, other people call it other things, is setting at the center of a ability to share information from all the different components that make up the built environment. So geographic information, budgeting information, facilities management, operation and maintenance, the information that's being built in the models, the Revits and the Teklas and the ArchiCADs and all the other little BIM software tools, energy information, live data from thermostats and sensors and all those things. All of those are now feeding to a central point and flow back and forth within the tools that we have available. And it's getting more sophisticated, more developed all the time. One more, Kimon. As we show these, we're going to show, I think you're going to see right after I finish, Dara's going to talk about a major project in China. Kimon will show some major projects that they've been working on all over the world. But these things are happening at a much smaller level. This is one of my clients. It's a single facility school district. And people at all levels are using this. It hasn't quite gotten down to tying into residential Internet of Things quite yet, but it can. It is definitely, though, getting down to the level of tying in at a single school. In the case of this one, it's a school that's been built over a 50-year period with buildings at all kinds of different times. But these technologies we're talking about now allow you to step into a facility where some of the buildings are 80 years old and have almost no sensor type of information with them, and other parts were built yesterday, and you're able to step in over time and in a cost-effective way implement these technologies. And one more, Kimon. One of the leaders and the first in this, and this is a graphic from the Coast Guard when Kimon and I were working on a project they called the Shore Facility Capital Asset Management Roadmap. People have been prototyping and working on this for many years. This graphic, I believe, was done in 2002 or 2003. So there are people that have been doing this for major owner groups for many years. And one of the first lessons they learned is they had to focus on their assets, not just their projects. This is something that when you focus on a project, what you're doing is you're looking at a very time delineated piece of work. We start the project, we finish the project, we move on to the next project. When you focus on assets, you basically have more of a continuum. You begin to view the world as a continuum. So one of the earliest lessons these clients learned was they had to focus on assets. And they learned that you can actually, with these technologies, you can connect assets. So in the case of the Coast Guard, they were connecting their ships and their boats to their facilities to make the interfaces between them work better. Come on, one more. And the Coast Guard's not by far the only one. This is actually the barracks at West Point Military Academy. And in this case, the owner is looking at having to do major renovation to major historic infrastructure, historic barracks. And they have thousands of cadets that are moving in and out of spaces. They're having to do the chess game of moving people from one area of an occupied building to another area in a very constrained environment, where basically what these graphics are showing is how you manage the overloading of spaces, how you manage your crowding within the framework of contractor laydown and contractor access. And so in this case, this is a mashup between all of those things to be able to study them in real time. The clients that have been doing this type of thing have now gotten to the point where they're actually able to create views of their information all the way from the satellite view, zooming right in down to the smallest widgets. And these are what I call little red blob models. Okay, so they're just screenshots of live data that's on, in this case, I think all three of these on Google Earth, where you're zooming into a campus, and in the campus you're zooming into the buildings, and but at every level the data that's here is live. You can get to any data at any granularity you need, and you can manage millions and millions of square feet, hundreds and thousands of buildings, all in one interface, where before these were kind of rigid graphics, they were fixed points. These are now, every one of these blobs is a live model. The one on the left is actually a model that we generated for my new book. It's actually accessible, it's publicly accessible, where you can actually see how you can drill down into these. And Enuma has actually made access to the models within this available. You just need to basically contact Kimon, and he can hook you up. Okay, one more, Kimon. And I want to leave this with a graphic. This is actually from a museum exhibit at the Denver Museum of Nature and Science. And they were talking about the Titanic. You know, the common wisdom is Titanic ran into an iceberg, sank, and killed a lot of people. Well, if you get into the detail of it and down to the level that we would need to get into with a building, where you're looking at really what is the cause of the problem. The cause gets down to small things, and as you see in this graphic, and I assume anybody who wants it, Kimon will give a copy of this whole thing too. But if you read this graphic, what you'll see is the Titanic didn't actually sink. It, you know, the cause at the time was running into an iceberg, but many things contributed to the Titanic actually sinking and all the people dying. And it's all those things that we now have the data to get to, and that we have to look at, rather than just focusing on this wonderful ship that's never going to sink, that couldn't be possibly damaged by anything. We have to learn. We really have to get down to the details so we can find the things that Kimon calls the train wrecks before they happen in our facilities. With that, I'm going to hand it over to Dara, and he's going to talk about some of the train wrecks that they handled in Disney in China. So, Daryl, off to you.
Great. Thank you. Can we go to the next slide, please? So this presentation will be my field notes from my experience at Disney Shanghai. I was involved with this project for about 2.5 years, and I spent time on the site during the construction of the park. So this is an image of the park on January 17, 2014. How it was about 3 years ago. So this is 1.5 meters below the elevation, the finished elevation of the park. As you can see, the contractors are there, the workers are there, CMU blocks ready to pour the foundation. And from there, we had to go to this. This was 2.5 years later, on June 6, 2016. That's when the park opened. It was a very fast-paced project relative to its sheer magnitude. The orange area is the area I'm going to focus on. This is called Mickey Avenue, which is the equivalent of Main Street in any Disney park, and it's very typical. It's on axis with the castle. I was involved with 4 buildings on Mickey Avenue. The next one, please. The buildings on Mickey Avenue consisted of character facades. So we had about 70 numerically assigned facades, and each facade, as it turned its corners, turned different corners, would have more. So we had about 200 facades to work with. Next one. And one of the main ingredients of a facade in a Disney park would be a TCP, seam cement plaster. And did a very rough calculation. We had about 8,000 square meter of plaster to work with. It was a daunting task. During construction, we had a close collaboration with construction workers, with the CM, we had art directors, and also a creative director going from facade to facade to make sure everything is happening correctly based on the design intent and the drawings. And also another ingredient was the AO, the architectural ornamentations, that attached to the building. We had about 700 parts, but each part had sub-parts, so we had thousands and thousands of pieces that we had to keep track of prior to and during attaching to the building. Next one. The building structure was quite simple. We had a spread footing, and the footings were attached to one another using grade beam, and then we had stem walls, and then the slab would be resting on the stem walls. So this is an example of the first building. The contractor decided to use a CMU block to do the formwork for the foundation, and it was a very irregular geometry, the foundation. But then he also decided to tie the rebar cage away from the foundation and then lower the one geometry to another, and that caused a lot of problem. The sequencing was all off, and we lost about a week from our schedule. So that was the time that we knew we were going to have a lot of problems ahead of us, so we had to come up with solutions. This is a typical building structure. The building would divide up into two segments. We had the primary structure, steel moment frame, and then we had the secondary structure, which was welded connections connected back to the building. And these secondary structures served as a skeleton of the facades. So it goes to this. That was a building about 85% done. And you can see a lot of activity going on at the same time. So sequencing was a major challenge, and also being able to allow all the trades to work with one another to hit the deadline. Next one. So the challenge for us was how to keep track of all this. This is another view of a facade. There are many, many stakeholders involved with a themed building. Our job as architects was to get all the input from the stakeholders and aggregate all the information. And one of the things that we did was rely on software for the long term. This is an example of the evolution of the structure of one of the buildings. We started with Revit. We had all the information in Revit. Then we migrated the information from Revit to Tekla to the structural model. From the Tekla model, we were able to create a fabrication drawings, and then from the fabrication, we were able to do the framing of the building. And as you can see, March 2016 was the final product. So it was a 3-year cycle, but we were able to use software for the long term. And that's another example of utilizing Revit, utilizing AutoCAD, utilizing Tekla, and viewing things in BIM site to be able to ultimately construct the facade. Next one, please. And that's a view of the facade when it was done. We go next one. Also throughout the project, we did a lot of 3D scanning. So from going from one phase to another, we documented every single step, and then we did a lot of comparisons between what was built and what was designed in order to identify problems. And it was a really good tool to be able to communicate with the contractor. At least we had tangible documents to show the contractor to be able to fix. Next one. That's another example, another instance. This was the glass canopy of the main entry. Early on, we knew that this was going to be a very challenging geometry, and we couldn't rely on a traditional method of designing it in-house, hand it over to the contractor, and expect the contractor to build it. So we were very closely involved with the design, fabrication, and implementation of this canopy. So these were models that we did with the contractor, layer by layer, and to be able to control the geometry in the computer. We did sequencing diagrams for the contractor in order for the contractor to install it properly, because the sequencing was a major issue, especially in the Chinese market. And as architects in the US, we don't really dictate sequencing or means and methods to the contractors, but over there we realized that we really need to do that in order to get the job moving forward. And we would show up to the job site every day, document the progress on the canopy. So this is when the secondary steel would come in, or the miscellaneous steel, would photograph it, compare it to the information in the model. And the next day we would come, would document the installation of the different components of the canopy, such as the bottom track, the gaskets, the glass, and every glass was numbered based on the panelization exercise that we had done earlier. And it went forward, and this was the final product. Go to the next one. So for us, the challenge was that we realized during the project, if we were to be in reactionary mode and react to everything one problem at a time, we will not be able to get the job done. So we decided to invent processes as we went. We got into tactical mode. We had architects, we had construction managers, and contractors all working together every day, going facade by facade, fixing problems, and work outside the initially agreed upon boundaries of the contract. We just went in. If there was a problem, we would fix it right away, and we would move from problem to problem to be able to deliver the job on time. And this is an image I took a little bit before the park opened. We had a soft opening, people walking around. So that's it.
Great, thanks, Dara. This is Kimon again, and it was amazing. I actually came out to visit you there on site. I think it was a little bit over half a year before it was scheduled to open, and this street was. Yeah. Put my foot down and it was covered in mud and a foot down. But it was a lot of activity, 24 hours. I think it was 24/7 at that point. And
24/7, yes, yes.
Seeing this come together was great. Great.
And this is Mike Bordenaro. I want to point out that the sequencing diagrams and that material that was created is not only helpful in getting it built, but then it remains the record for repair and any other work that needs to be done in the future. And Dara had explained that too, specifically that the canopy was really complex, and if a piece of glass breaks there, they're going to need those documents to know how to fix it. Is that pretty accurate, Dara?
Yes, that's correct.
Great. So let's move to James Salmon.
Hey, Kimon, how are you?
Good, welcome.
Glad to be with you guys. My presentation today is going to focus in on the legal instruments. One of the problems that we have in the industry is that we do not have a set of modern procurement laws and regulations that fit with this new generation of tools that we're using. I use the kind of cobbled together analogy of Sisyphus, the frog, and the iron triangle to explain where we are. In the traditional contract negotiation realm, we're pushing the rock up the hill like Sisyphus. Most of the industry acts like the frog being slowly boiled in the pot, pays no attention to the increasing heat from innovation that's raising the cost to everybody. And we treat scope, cost, and time like an immutable iron triangle that cannot be impacted. We need to replace this entire broken, fragmented, adversarial, and distrustful process with a smart built culture that is integrated, collaborative, and trust-based. In order to do that, we need to rethink our approach to negotiations. And if we do that, we can retire Sisyphus, crush the iron triangle, and turn up the heat on the frog. A new approach to those negotiations involves us taking integrated legal agreements that are traditionally negotiated in a very adversarial way and moving those forward much more quickly. What that does is it arms us with a set of tools that allows us to transfer transfer information like these old aqueducts used to transfer water downstream. We can transfer information in the same way. On the right-hand side of this slide, I've got a set of images here that I used to use to try to explain what we were doing with this iron triangle. Everybody seems to think in the built industry that scope, cost, and schedule are absolutely immutable. And it is true that those are your starting points, but it's important to remember that we are wasting 60% of all of the resources that we allocate to a project. And if the old saying, if everything if everything looks like a nail, you know, then the only tool you deploy is a hammer. That's what we've done in the built industry. We try to hammer on these 3 corners, and there's a better approach. If you want to jump to the next slide, Kimon. I think that in the context of crafting the next generation of integrated agreements, that we can get away from this scope, cost, and schedule approach and tackle this problem in a lot better manner if we move our laws, regulations, and procurement legal framework back into the programming and planning phase, and if we bring more people to the table earlier. So in the last slide, we were looking at that iron triangle, and we had value and quality inside the iron triangle, and we were hammering away at the points of that iron triangle with our hammer. If we will instead encircle the project in a collaborative circle that provides both innovation, and I say that innovation brings a lot of pressure to bear on the people that are involved, and if we will also bring competition into the process in a healthy manner, healthy competition, those things combined with the value and the quality will allow us to press hard on scope, cost, and quality. And since we have a 60% waste rate in our industry, if we squeeze all of that out of a project, we wind up with a project that's a diamond. You know, when you put carbon under enough pressure, it turns into a diamond. And that ought to be our goal. And the way we achieve that is by putting everything under intense pressure. So how can we do that? How can we really revolutionize the way we go about putting together legal instruments in this realm? One thing that's coming, and it's coming very quickly, is something called a smart contract. Now, we've all experienced smart contracts on the web. If we have a banking application, if we have the ability to access our information over the web, it's simply a self-executing contract that uses software to increase efficiency and productivity and to automate workflow. We're seeing more and more of these smart contracts in the regular cloud, but many are going to be deployed in the not too distant future on the blockchain. And the blockchain, which is the technology that underlies Bitcoin, is a very interesting tool. The main features of an effective blockchain is that it will be open, distributed, validated, secure, and synchronized. And it's an open source online ledger that provides an accurate digital record of assets. And if we take that emerging blockchain tool, which you might think of as an operating system on the web, we're going to find some really interesting things in the very near future. So I said that there are several different features to an effective blockchain. The first feature is that it's open. It's an open ledger that everyone can review. And if it's open, then what that means is that we have access to the data, and that means transparency. And in the build industry, I always take the position that sunlight is the best disinfectant. If we want to be able to peer into every dark crevice of a project, if we have open books and we can really go after waste, then we can do something about that 60% waste rate. Smart contracts written on blockchain will accelerate the opportunity to use open transparency in this environment. Next, it's distributed. So a distributed blockchain concept means that it is all over the world at once. And then the next important thing is that it's validated. In the context of the Bitcoin realm, Bitcoin miners validate each transaction as it occurs on the blockchain. And the final element is, jump to the next slide, is that it is a secure in this blockchain environment. Now, there are a lot of different ways that we could leverage the blockchain in the built industry. And I want to spend the last few minutes here discussing those things. For anyone that wants to delve into the blockchain in more detail, there are a lot of good summaries on YouTube, and I've got a couple of recorded presentations that I'd be happy to share with you. One more, that synchronized is another feature of it. Jump ahead one more, Kimon, and I'm going to cover the principles of the blockchain very briefly and then get into some construction related apps. One more, Kimon. So the principles that underpin the blockchain is that it has networked integrity. So the integrity of the system is actually a part of the networking of the blockchain. It's a distributed network, so we have the power to distribute that network broadly. It has value as a common core that's everybody is vested in. Privacy is really important on the blockchain. Again, security, and then it levels the playing field for a lot of different people around the world. And then finally, it'll help us secure our rights and secure our information and our data. So let's think for a minute about ways we might leverage this in the not too distant future. Dara was talking about leveraging this laser scanning to compare as-built documents to the BIM and determine whether the contractors had completed their task properly. If we were to automate pay applications in the built industry, we could save many hundreds of thousands of dollars, if not millions of dollars, by simply paying pay apps as they came due directly out of an escrow that was available on the blockchain. RFIs are another area where we could really make good use of this. BIM already does a great job of this. Our virtual planning and design tools allow us to handle what I call virtual RFIs instead of physical RFIs. That is a much more efficient process than we've used in the past, but in many instances, all we've done is digitize an existing antiquated paper process. With something like the blockchain and good virtual planning and design tools, you can draw a straight line from the trade contractor to the decision maker and have decisions made instantly and bypass much of this. Jump one more, Kimon. There are opportunities to put the permitting process on, make it virtual. We're already seeing a lot of this in the virtual planning and design realm. The blockchain technologies may advance that even further, even more quickly. One more, Kimon. Schedule, the bane of every construction project, and especially construction lawyers. Very, very bad memories of all kinds of schedule failures. They could be moved on the blockchain. They're already being handled by Synchro and things like that. So where people are in this space, the entities that are involved, you will see Bitcoin, you'll see Ethereum, you'll see Dash. Those are what I call the first, second, and third generation blockchain that are out there. They're advancing even more quickly in the private sector than they are in the public sector, but I'll give you two examples of players in this space that are very interesting. The state of Delaware is moving much of their records onto the blockchain. They intend to put the UCC code on the blockchain, and ultimately their goal is to put their stocks that are issued by entities that incorporate in Delaware on the blockchain. That is an amazing development, and as that unfolds, we're going to keep our eye on it here very closely at BYH. But that could be a very revolutionary thing. The R3 consortium is another entity to keep your eye on. The R3 consortium is made up of 19 different banks around the world, and they have now syndicated a loan, created all the paperwork for that loan on the blockchain, funded it on the blockchain and made payments on the blockchain. So this is all coming at us very fast, and it's all very interesting, and anyone that wants to learn more can delve into the web and find a lot of information about the blockchain. It's very interesting. It's no longer your child's blockchain where they were dealing drugs and paying for drugs and doing things on Bitcoin that were all skanky. It is coming to us in real time.
Great, thanks, James. And it's also, Bitcoin has been in the news recently about all the hacking that's been going on, and so if the bad guys are using it too, it means it actually works. But how do we turn around and use it for something good? And that's what we are trying to do with the Building Smart Alliance of thought leaders. We're really trying to push the limits of our understanding of what assets in the built environment and the building industry can do, because in my opinion, a lot of knowledge exists out there, a lot of very valuable information that is trapped in documents and files and even BIMs. If you imagine each of these books being a solitary BIM that's not connected to the world, the value of it really diminishes. So how do we transform the building industry and asset management, for example, into something that's more searchable, and using the technologies that have existed for a long time now? It's really time for us in the building industry to look at that world and see how we can capture that value. We run across this all the time in our work as architects and our work with the projects I'm going to be talking about next. Documents that look like this that are searching for information. So in the design of a hospital, for example, is the radiology really department number 286, and spent thousands of hours in a project just finding stuff and confirming information that this is all just data. I mean, come on, we're used to looking at our smartphones and just Googling anything now, but the building industry still has a long way to go, which means there's a lot of opportunity for us in the design, construction, and asset management world to think in terms of data as information. And as James showed, really data doesn't matter what it is. It could be data about contracts, it could be data about budgets, about buildings. It really doesn't matter what you call it. It's all just data in our world. And the strength of us understanding this domain of being in the building industry is we understand how this data is connected to location and parts of the building. Just like Dara showed, we get really into the nitty-gritty and we understand how buildings go together. And that's a unique expertise that we're not really leveraging and using efficiently. That's an opportunity that if we don't take right now, we are going to miss it. So this is a National Institute of Building Sciences series of projects that were for the Department of Defense, Defense Health Agency, and Department of Veterans Affairs for healthcare facilities. But if you take the word healthcare out of this, it could be anything. It could be Disney, it could be school facilities. Essentially, it's a collection of information in static format that is on websites or in documents that is used to define the requirements for a project, for example. So if you're going to contract for a project, like James said, if you don't have good information going in, how are you going to even track, does it come back to you in a way that's deliverable as an owner that is of value to you? And that's what we looked at. We looked at these documents. If you squint and look at the thousands of pages of documents and PDFs that were, in fact, produced by even BIM, but then they were stripped away back into documents, you can see the value inside each word there, but you can't get to it. You literally have to sift through this information to get to it. The other challenge in the building industry and with Building Smart Alliance and Building Smart International and with the AEC industry, a lot of our projects are very monolithic in nature. They're kind of a large file that we put stuff into, like finance described, and then we have to get the data out of, and then we have to define the standards of how do we transfer this data. All very important topics and very important standards that need to be developed, but in many ways they're really trapped in the 90s. It's really that paradigm of let's put everything in one large box and then try and get it out to the next team. But the world today is not about files anymore. It's about transactions, just like Bitcoin. They're small, simple transactions that are incredibly powerful and fit into the larger picture. So we're familiar with vehicle identification numbers, basically NID. It does not have to be complex. That's another challenge that we've had at Building Smart International and Building Smart Alliance over the years, I think, is that we spent a lot of time developing standards, documenting them, putting them into binders and distributing it. All important stuff, but really if we start with just the very simple stuff, it's really that ID, if you track that ID about a vehicle, you can track what happened to that vehicle, who owned it, what accident got into, what was done to it, and then even how you dispose of it. What's the value of that as it goes down the line? It's just that simple ID. It's not a three-dimensional beautiful model of the vehicle. It's an ID attached to that. And that's what the building industry and the asset world really needs to think about, is how do we think in terms of taking an owner requirement, for example. Owners have requirements for a healthcare facility, and this is actually the NIBS project that I mentioned earlier for VA and DHA, Defense Health Agency. You have a stack of documents. These documents, when I say documents, they could be PDF files or even BIMs. They're just a stack of things that you can't get information out of very easily. Then the owners say, we want to hire an architectural team to go and build this project, and we're going to hand them the stack of documents that are not coordinated, by the way. There are conflicts because there are static files from years ago even that are parked on a server somewhere and said, here, go get this requirement for a hospital. And then the architects have to be paid to digest all this data, reverse it, and then design and build a building, a project. And then they deliver that data back to the owner and say, here you go, here are your assets and information that you manage for the life cycle. If we don't have consistency of what we require and how we use this data, we're not going to get into a world of managing assets in the life cycle consistently. And it does not have to be complex. I want to stress that over and over again, because BIM can be incredibly powerful and incredibly valuable for a project, just like Dara showed. But a lot of the information that the owners are looking for is very simple. It's we want to track this piece of information, just like the vehicle or that blockchain that James talked about. It's very simple stuff from a technical point of view. We're overcomplicating the development of standards and the building up of the capability for the industry. So if we overcomplicate it, it becomes very difficult to implement. We have to start simple, and we have to start implementing before continuing to develop standards. So in the space and equipment planning system, these owners that we guided to this approach for the National Institute of Building Science project, we said, okay, you have data and you have knowledge in a database that's not accessible. Make it publicly accessible on the web. So if you go to seps2bim.org, you can actually get to their knowledge base and tap into it with a transaction. Say, what do you think you need to go into this building? What type of equipment do you want? What type of spaces do you want? And with that simple message, that simple rule can be applied to projects across the board consistently, which will deliver data back to asset management in a consistent format. This is already possible today. It's just about, but there's obviously issues with contracting and with industry being ready to do this, and the amount of waste that goes into a project, just like James talked about, it's astronomical, I think. And we went to a presentation last week where a presentation was made that up to 80% of a lot of the effort of digesting and getting data into a project is just literally waste. It can be automated. So how do we get this value add? And it does not have to be complex. That's how the web runs. That's how Bitcoin and blockchain took off. It's simple transactions with simple instructions, just like Legos that say, here are the kit of parts that we need to build a building. And when that building gets delivered back to us, we want them named in a certain way so we can track that asset all the way down to the component level. What was that pane of glass that Dara put into that canopy in Shanghai Disneyland? That has an ID associated with it. It started somewhere. So it's not about only modeling the detail of the building, but let's get to getting the data to flow, because that's the first thing. The data associated with that geometry lets us track that asset for the life cycle. And that technologically is already a done deal. It's already been figured out in other industries. We're just way behind in the building industry, which means it's an opportunity for us to manage these assets in a more efficient way. So we challenge the industry that if you think in terms, owners have data and knowledge, you have the capability to plug into that, and you have the capability to pull that knowledge as a transaction. You don't need the entire data set. You just need that little bit of information to do the work that you need to do, whether it's a financial transaction or a legal transaction or construction transaction. It's not a monolithic model only. The model is important, but to track the assets, we need to think in terms of how do we get into modular, smaller pieces. And that opportunity exists today. And the other message from the NIBS, National Institute of Building Sciences perspective, this is another project that's ongoing right now with the State Department. Other owners are seeing the same type of value that can be applied to their projects. So it's not just for healthcare, it's not just for large projects, it's not even just for large AEC teams. You can have a very few people, very small team of thought leaders, like we've been showing here today, to actually have a lot of impact. And the other message really is think in terms of open source tools. There are proprietary applications out there that are incredibly powerful, incredibly important for our industry, but we need to think in terms of how do we open things up and connect the dots, just like Bitcoin and blockchain did. It's about open access, controlled access. It's not a free-for-all. So we've initiated at the Building Smart Alliance open source tools that are actually on GitHub that you can actually get to, that are about tracking assets and information for a project. And I know that other organizations like BIM Forum and Building Smart International here in the US have been doing this as well too. There have been discussions of how do we share resources. Let's not reinvent the wheel. Let's pull these things together and actually get things done. And the most important thing is actually deliver something that's functional. Because if we want to manage the complexity of the building industry, we're not going to get there by just talking about it for another 10 years. We actually have to implement small, simple applications to track assets, to get the job done, and challenge the owners, the large owners out there that have the power to make this change. The government agencies that we are paying our taxes to, they have the power to make this shift. They're doing it in the UK. Why can't we do it here in the US? We need to use that power that we have to change the industry. And I invite you to join us as the Building Smart Alliance thought leaders and other organizations in the industry, Asset Leadership Network, the BIM Forum. There's a lot of great organizations out there that have the brain power. We're all there. We're able to connect the dots. In our group, the Building Smart, as you saw, we have thought leaders in the building industry. We have boots on the ground, people that deal with buildings. We have people that know the finances and the legal aspects of it. And we have technology experts that can pull it all together. It has to be a collaborative effort. And we really thank you for listening to us today. And we'll go into a discussion now with the participants. Before I leave that, actually, we have a lot of webinars that we've been taping and putting online. If you go to the website, you'll see what's coming up. There's even one next week. There's several coming up with these different groups, so you can see that on the website. And let's see. Let's go back to the discussion here. Are we all online? Can everybody hear?
Yep, got it.
I'm good.
Good, great. So we're all here. Okay, great. So what are your initial thoughts? Maybe we go back to finance since you started this off. What thoughts do you have about this discussion we had today?
Well, I think what I'm hoping everybody gets from this is that there are a lot of opportunities out there to jump past many of the very complex and hard to implement things that are going on. The architects and the designers and the construction people are still going to have to build a building. Somebody's going to have to get their hands dirty and actually do the work. But there are many ways to do the work easier and with more efficiently for the long term than we're doing right now. Many of the things that have just been industry standards forever are already starting to go by the wayside, but they're going to go by the wayside faster, just as we've seen in the telecommunication industry and the airline industry and all over the place. There are changes that are happening that make our work life easier and more, let us do a lot more work, a lot better. And I urge everybody to really explore these things. And I think if you explore them with an open mind, you'll find that this is not the thing that we're going to have to wait for the next 20 years. This is today.
Great. And I see it as an opportunity for those that are willing to step forward. There are going to be casualties like we keep talking about, but the people that and the groups that are willing to collaborate and work on this, there are huge opportunities, I think. James, there's a question for you actually from Sandy that asks, do you work with the GSA FAS? I'm not sure what FAS stands for, but maybe you do.
Federal Acquisition, something regulations, okay. As all that stuff. I've worked on federal projects in the past. one thing that Fineth said that ties back to that I think is really important. Fineth said that a lot of the owners, their first lesson was that they learned that a project is different than an asset, and they learned to treat everything as assets. Unfortunately, the last lesson they learned is that they have a broken procurement model, and that we are busy procuring planning, design, and construction services out of silos and pursuant to a broken set of legal agreements and regulations, FAR, among them federal acquisition regulations, that literally were designed to procure mules for the U.S. Army in the 1860s. And we're still using many of the same documents. I did a presentation where I tracked language from an AIA document all the way back to an 1872 treatise in the UK. We are recycling a broken set of legal agreements, and that's one of the things that I want to press the big owners, the public owners, the both at the federal, state, and municipal level. There are very, very good integrated procurement models that we can leverage that are being used every day in Canada, every day in Australia. There are people around the world that are getting this right, and there's no reason we can't do it too.
That's great. Yeah. So actually, you mentioned the AIA documents, and all of us, Fineth and I and others are involved with AIA as well too. But we hear the word documents, and it kind of scares me a little bit too, to think in terms of, imagine if we were going online and we were talking about documents that you have to download to buy a airline ticket. You basically create the transactions and you run with it, right? And that's kind of what your presentation was about, James. But how do we challenge the industry to think in terms of that, transactions and agreements, and knowing who the end user is to interact with that user? And that's kind of a software development kind of a concept, is you build for that end user. You don't think in terms of the functionality. You're adding more and more weight to the software to get the job done. And that's why these apps on our mobile devices work. There's no training involved. You basically push a button and you go. Dara, that when I was in Shanghai visiting you, and you mentioned this, that the teams in the field that were building all that incredible project, a lot of them were very inexperienced, right? They were coming from the countryside and given the hammer or whatever or tool to do the work, and you essentially were digesting the requirements of a complex project and giving it to them in a format that is understandable to them. So in a sense, you were kind of the interface to the complexity of that project to describe that to them. Is that correct?
Correct. So we had to do a lot of diagramming. We had to do a lot of simplified drawings for them to break it down, or we had to phase it for them step by step for them to be able to execute. And also we really relied on mock-ups. So we did a lot of mock-ups prior to doing the actual construction to be able to train them. Again, that was a huge cost for us, but we had no other choice. In order to be able to deliver a high-quality product, that was one of the necessities, to be able to do mock-ups and do training.
Great. Thanks. We're getting close to the end of the hour here. Is there any other final statement that you'd like to make, Mike? Is there some wrap-up you'd like to do, or anybody else? Just jump in. But
well, I'd like to thank all of you for taking the time to put together this flood of information. Dara, that was just really incredible to see what was done in such a short period of time and how the documents were maintained and could be used going forward. James, you always have new and leading edge things to say. Let's try to get that message from Delaware up to the federal government. Asset Leadership Network will help you with that. And Fineth, you always put things in a way that makes big pictures clear and simple. Kimon, that goes for you also. One of the things that's really great about this coming together is we're talking about breaking down silos, and by having the National Institute of Building Sciences, buildingSMART Alliance Thought Leadership work with the Asset Leadership Network on a webinar series that included support from the National Academy of Sciences, I hope we're breaking down some of the silos ourselves too.
Great.
So thanks to everybody, and please join us again next week as our series, webinar series continues.
Thanks, Mike, and thanks to the Asset Leadership Network for sponsoring this series, and thank you to the National Institute of Building Sciences buildingSMART Alliance for sponsoring, and we're 6 seconds away from the top of the hour, so we're going to log off right now. Goodbye, everybody. Thank you very much.